Good morning, colleagues. Today we are going to solve exercise 3.8 from the book Fundamentals of your Sadiku Electrical Quota. In this exercise we are asked to determine the attention V sub 0. As before, what I advise you is to reward the circuit in a way that you understand it better, and in this circuit, we observe that it has a dependent voltage source where it depends precisely on the voltage. Now, first what I do is draw the circuit again to make the analysis easier for me. This is optional, right? You don't necessarily have to redraw it. But when you are starting to analyze and apply, I would advise you to do it, since when you have the brief experience, you could avoid this step. You know that here the only thing I used is the rebar to change the position of the resistance of a name with a 3-point voltage because they are in series, so the location does not matter. And here comes the resistance of 5. Then comes a dependent voltage source as 4 times B sub 0, so it would be 50 well. Now they ask me to determine sub-0 by applying nodal analysis. So, I'll stand here and I'm going to give this a name. I'm going to call it B. And I'm going to do a visual analysis of where the currents go. Depending on the voltage source, I believe that the current should take this direction here. Here the current must take this other direction. And therefore, 2 currents are going to enter this node, which is this one, and a third one is going to come out. It would be this one, right? Note that the polarity of versus 0 also gives me a brief clue as to where the current enters this resistor. So I'm going to name the currents. I'm going to call this one I1. This one I'm going to call I2. This one I'm going to call I3. So, at that point, the sum between I2 and I3 is going to give me the current I1, which will then polarize that resistance. So, if I stop here, I'm going to locate this. I'm going to first analyze the currents that enter the I2, depending on the voltage B3 minus B1, then it would be P3. What a pity it is 3 volts minus B, if 3 minus B over 1, plus the I3, and the I3 is 4B over 5. All this is equal to the I1, and the I1 is B, that there is one the current that it has here, since it is the voltage of the sum between 3 and 2, 3. Ohms plus 2. Do you see the chat? I'm still not locating it. Well, I have this species. I'm going to do is first 3 minus B. If you're divided by 1 is the same, plus 4/4 B sub 0 minus B over 5. All this must be equality. B over 5 2. 3 plus 2 is 5. Now, what else? Well, I'm going to move on to the side. The values are the same. I'm going to do the operation. I'm going to operate here. Here I have a variable called B sub 0. But that variable V sub 0 is the same. Let's look. So far we have the thing, and B sub 0 as a voltage divider here, right? In other words, the voltage that exists here in the 2 ohm resistance, the B sub 0 is a product because a current comes here and here it is multiplied by this resistance, so it gives me this voltage. Notice that I know that P sub 0, it's like in a disol, it's going to be the same. The current that circulates through this resistor, well, the B that had previously attracted attention, right? At this point, it is this same one. Remember, the B divided the V divided in the street voltage 3 plus 2, versus divided by plus 2 equals 5. Here in the current that is going to circulate here, the current in this case would be the I1, and if the current I multiply it by the resistance of 2 ohms. If I multiply it by the resistance of 2 ohms, it will give me the voltage V sub 0. V over the resistance is current, multiplied by the resistance that is here, since the voltage in that resistance, B is sub 0. So I already know how much B sub 0 is worth, and that and this B sub 0 I'm going to replace here. So I continue with my equation, and I'm going to continue here. So here I make how I'm going to place the variable minus B sub 1, minus B. What a pity, that's minus B, plus 4/5. What? Sometimes multiplied a 0 and sometimes a 0. We already said it was all of this, 2/5 of AB. V sub 0 is the filters of B. All of this is B sub 0. Two-fifths of B minus B fifths minus B fifths. What is here is going to happen to the other side the same. It is going to be minus again B fifths. Same, and I pass the 3 to the other side to minus 3. Okay, so I continue operating. I have to mark minus B plus 4 times 2 8. 5 times 5 25, 28. Of B minus B over 5 minus B over 5 equals negative 3. So if I add negative 1, negative plus 825 minus 1/5, minus 1/5, and you can check it on the calculator. This is going to give me negative 27 over 25B equals negative 3. So, if I solve for B, I'm going to get that B is going to give me 2.8 volts. Now, that is the voltage at this point, and they are asking us for the voltage here at this point. Well, the voltage at this point is here, which was the division of voltage, where the voltage over the resistance that is in this branch gives me the current, and that connects multiplied by the resistance, gives me the voltage. So, P sub 0 here, almost equal to B over 5. 2.778 over 5 times resistance 2, which is a megadad 1. So, that voltage goes sub 0 for this circuit here in this